All right, friends, it's T-Man, and I'm back with. We're gonna do an educational video today. Now, I've mentioned this NCBI report already. I put it in what's it called? A video I just did, okay, on somebody, on a lifting slave. But I'm gonna review it with you anyway, just in case you might have missed it. So this is a bodybuilding muscle report from NCBI. The effects of muscle loading on skeletal muscle regenerative potential and update on current research findings, yes, relating to aging and neuromuscular pathology. Okay, that's all really nice, but we're really only interested in the muscle stuff, okay, regenerative stuff and muscle. Muscles are based on regeneration. To build muscles, it's all based on what does it say here? Regenerative potential. Now, your regenerative potential as you get older, I can't tell you. It may be going down, it may not be. Maybe it's your fake diet that's preventing it. Maybe it's the tap water, the faucet water is poison. I don't know. Maybe it's the swimming pool, the chemicals. I can't really tell you, okay? A lot of things can prevent a lot of things. So, skeletal muscle is dynamic tissue with remarkable ability to continuously respond to environmental stimuli. Among its adaptive responses is the widely investigated ability to skeletal muscle to regenerate after loading or injury or both. Okay, all right. That's not important. I'm not going to go over this stuff. All right. Regeneration. It's always satellite cells. I told you, stem cells, whatever you want to call it. Yada 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 yada. I went over this part over here at the bottom. Well, this part's really bad here. It tells you about sarcopenia, age-related sarcopenia, and dysfunctioning of the neuromuscular system. A lot of people get that. Okay, general events surrounding skeletal muscle fiber regeneration. All right, because some people were asking me, how long does it take? How do you get muscle damage? And then when you do get it, how long does it take to repair and remodel? Yada, 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 yada. And a bunch of stuff, broski. So I'm going to go over this. I'm going to go over this report with you guys, all right? In case maybe you have never come across it, I don't know. So muscles can be damaged by trauma, disease, or even some type of exercises. Yeah, definitely, exercises, yeah. It could be damaged all kinds of ways. A muscle could be damaged all kinds of ways. Now, the type of damage you're looking for is the repair and remodeling type of damage, okay? You don't want to get your muscles damaged with disease and try to grow muscles through disease. That's not going to work for you. All right, and a bunch of other things. So they're talking about exercises. The most notable exercise induced damage is in response to eccentric exercise. I told you, it's never concentric. It's always eccentric exercise. Everything is eccentric. Skeletal muscle healing after injury or micro trauma. We're looking for micro trauma, okay? We're not looking for severe injuries. But you could call micro trauma an injury. It's still considered an injury in science. They refer to it as injury. Micro injuries, what do you want to call it? Okay. Micro trauma caused by exercise. Micro trauma caused by exercise. Yeah. But it can only happen in an unaccustomed bout of exercise. I can prove it. It tells you science. Look it up. Unaccustomed exercises don't cause widespread muscle damage, okay? It doesn't say trained muscles do not cause damage, okay? They're adapted. All right, anyway. So, yeah. Where was I? Caused by exercise has been divided into 4 interrelated and time-dependent phases. These phases are necrosis, degeneration, inflammation, and repair. So there you go. There's a necrosis, there's a degeneration. That's why muscles have to shrink before they can get big. They have to clean the T cells, whatever, the macrophages, they have to clean up the dead tissue, and then it has to regenerate new fibers, getting it bigger and stronger. It's going to repair and remodel even stronger. Okay, dude? So, yeah. Scar tissue formation, fibrosis. So there's a necrosis and a repair. There's necrosis. Degeneration of the myofiber is characterized by disruption of the plasma membrane and basal lamina, resulting in an ingress of extracellular calcium and subsequent autogenic degradation of the damaged muscle fiber unit. Within the first day of injury, the area is invaded by inflammatory cells, such as mononuclear cells, activated macrophages, and T phytocytes. The subsequent secretion of growth factors and cytokines further promotes increased blood flow to the area and enhances the inflammatory response. Muscle regeneration begins once the phagocytic inflammatory cells have cleared away necrotic tissue. And that's usually like the first 2 to 3 days. That's why it takes a minimum of 7 days to repair and remodel muscles, and you need to be in positive nitrogen balance anabolic. You need protein synthesis, need to seek that breakdown. Inflammatory cell blockage impairs muscle regeneration. Okay, well, that's if you're taking these inflammatory pills. Don't take inflammatory pills, anti-inflammatory, because it's going to block it. It's going to fuck you up. You're never going to build any muscle. For example, non-steroidal anti-inflammatory drugs administration reduces important macrophage secreted factors that may play a role in myoblast proliferation and differentiation. Well, you want myoblasts because they're going to build muscles and myotubes and everything. Yeah. Therefore, the initial benefit of the inhibition of myofiber degeneration may be at the expense of functional muscle regeneration at later time points. The invader referred to brisk. Okay, the role of inflammatory process muscle repair. Okay, this part's important. Look at the top there. Active muscle regeneration typically occurs within 7 to 10 days. It's always like that. 7 to 10 days is the minimum. This is the minimum. From the time of injury, peaks at 2 weeks. Well, you can see there's a peak at 2 weeks, but you can come back and damage these muscles, okay? That after 7 or 10 days, depending, if they've been repaired and remodeled, they will damage. If they weren't repaired and remodeled, then they ain't gonna damage again when you come in the gym, because you're gonna go, hey, I'm not getting the same damage like I did the first time. Yeah, because they weren't repaired and remodeled. You did something wrong. You either didn't sleep well as well, plus you didn't eat enough. You weren't in an anabolic growth state. You weren't in a positive nitrogen balance. So it says gradually declines within 3 to 4 weeks. That's if you're getting a very severe injury. We're talking about micro traumas. So it's going to be like 7 to 10 days for micro traumas. And if it's a severe injury, 2 weeks and then 3 to 4, that's totally different, okay? Simultaneously, scar tissue formation peaks around the second week post-injury, although collagen 1 and 2 deposition has been observed in early as 3 days after injury. Okay, during the repair process, muscle regeneration and scar tissue formation seems to be in competition as each via the muscle area. Significant efforts have been dictated and development of biological therapies aimed at minimizing skeletal muscle scar tissue formation within the intention of enhancing regeneration. The regenerative process occurs. Skeletal muscle has been main subject of reminder of this review. Yes, the satellite cell is very important. Okay, that's the thing that builds muscles. Without him, forget it, dude. He prevents follistatin, myostatin. Give the post-mitotic nature of human myofiber nuclei. Remember, nuclei are post-mitotic. So if you're adapted and you're lifting in the gym, the nuclei, they do not split, divide, and increase in number. They have to be donated by the satellite cell, and it has to be activated, and only it can split, divide, increase, and donate its nuclei to that domain to support further muscle growth when it reaches a ceiling limit during hypertrophic process. Okay. Another progenitor cell population is necessary for regeneration to occur. The main cells in the regeneration of damaged skeletal muscle fiber are satellite cells, although it has been shown that the first week of recovery after injury or unloading does not require satellite cell activation. Well, yeah, because you don't need any more. You don't need any more. You reach ceiling limit or whatever. It's going to reach ceiling limit. You don't need any more now. In fact, satellite cell activation seems to account for only half of the force restoration after eccentric contraction-induced injury. Yeah, because there's other factors going on. There's myoblasts, there's fibroblast cells. They're all there, dude. They're all like around or whatever. Okay. Our laboratory has isolated the population of neonatal muscle-derived stem cells. Okay, ability to proliferate, whatever. This stuff is boring, man. I don't know what else to say here, but you get the picture, all right? Satellite cells are unspecialized mononucleated cells that in an uninjured state are interposed in a quiescent state between the muscle fiber itself. So listen to what they say. uninjured state. They're highly mononucleated cells that are in an uninjured state. So if you're adapted lifting weights in the gym and you're not getting any of these micro injuries, then it's quiescent. The satellite cell is not donating its nuclei. Is not supporting further muscle growth. So what exactly are you doing there in the gym? Get it? If they're activated by injury, but they're inactive due to uninjury, what are you doing there? Okay, anyways. The basal lamina, which surrounds the myofiber. The human remember, when the satellite cell is activated, myostatin, follistatin, they go away. They turn off. They cannot occupy the same space as the satellite cell, so they have to fuck off. Get it, dude? Yeah. They can't fucking stay there. All right. In human skeletal muscle, satellite cell content varies between muscles within different functional properties, different individuals with different physical activity levels and ages in the human vastus lateralis muscle, and number of satellite cells per fiber. A cross-section does not differ between type 1 and type 2 muscle fibers. Yeah, this is a known fact. In response to injury or overloading, as in exercises, satellite cells are activated, at which point they are considered to be, when they say overloading, they're talking about, I told you before, multiple sets have to be done to that muscle, an overload of that muscle by doing multiple sets to get it to damage, to micro injure, will cause the satellite cell to leave quiescence. Yes. Okay, myoblast cells. Yes, they form the myotubes. Myoblast, myotubes. All right, it's activated, at which point they're considered to be myoblasts. See, the satellite cells are now, what are they? They're activated, at which point they are considered to be what? Myoblasts now. They're no longer satellite cells. Within the scaffold of the original damaged myofibers, basal lamina, myoblasts assemble together and fuse to form what? New myofibers. Sounds like hyperplasia to me. Oh. Did they say exercise up there? Where? Oh, holy fuck, I just missed this. Didn't they just say exercise there at the top, dude? Where was I? I don't know where the fuck I was. All right. Yeah, right there, see? Didn't they say as in exercise? Overloading as in exercise? The satellite cell? Oh, it's creating, what is it creating here? Oh my God, let me scroll up again. What did it say here? Myoblasts assemble together to fuse to form a new what? Myofiber. Oh my God, dude. Yeah, they actually did that. Wow. Fuck, I know. Hyperplasia doesn't, I guess exist according to everybody online and Blaha and your fitness gurus. Each myoblast, man, I gotta get tired of doing these videos, okay? Each myoblast contributes a small amount of cytoplasm. Cytoplasm, isn't that what the muscle cells are made out of? Fuck me. And a new nucleus to the myofiber syncytium. It seems that the satellite cell proliferation is necessary to contribute what? Myonuclei for myofiber hypertrophy to occur after muscle overloading. Yeah. Importantly, satellite cells not only demonstrate an ability to fuse together or with existing fibers, but they are also self-renewing. Get it, dude? Remember, we want to increase the satellite cell pool for future regenerative demands. This is essential to reinstate a residual pool of satellite cells, which that these cells are available for future rounds of what? Remember, future rounds of regeneration or hypertrophy. So we got two things going on, regeneration and hypertrophy. See that, man? It is necessary for hypertrophy. Muscle damage is necessary. You're never gonna grow. You're wasting your time, dude. In cases where the satellite cell pool is not adequately replenished, that could be a bad sign. Such in the dystahane muscular dystrophy, or in aging, that's really bad, bro. So you better start increasing that satellite cell pool now. Regeneration is impaired. Holy fuck, regeneration is impaired. If regeneration is impaired, you're screwed. You're screwed, dude, and you're gonna die. Look, skeletal muscle. Oh my God. Population of quiescent satellite cells. Proliferation subpopulation of the stem cells. Oh my God. Activated stem cells, myoblast. IGF-1. We want IGF-1. Eat a lot of meat, bro. That's it. The IGF-1, broski. Wow, look how it's restoring and creating more muscle fibers. Isn't that incredible? Jeez, look at that fusion. It's fusing with that busted fiber, damaged myonucleated fiber. Oh, it's going to create more of them. That's great. Yeah, it has been suggested there are two sublets of satellite cells. The first of which is capable of what? Rapid differentiation. Just 48 hours from the time of injury. That's why it's important to head down to the buffet and eat for 4 hours straight. You need to be in a positive nitrogen. You need to be anabolic now. Okay. As evidenced by the early myogenic marker expression and another subset that demonstrates stem cell-like properties and undergoes prolonged self-renewal. Before terminal differentiation, muscle stem cells are defined as cells and possess the ability to produce both new muscle stem cells as well as myoblasts and myofiber progeny, without themselves expressing markers in muscle differentiation. Muscle-derived stem cells have the ability to differentiate into, oh my God, endothelial and neural lineages that all neural and vascular supply targeted skeletal muscle, enhanced regeneration, okay, yada yada. The differentiated cells into tissue seems to be independent environmental signaling. Yeah, I mean, I don't know. Should I go further with this? Because this really gets boring for me. A variety of alterations in surrounding evidence, satellite cells including mechanical and growth factors. Well, hormonal signal might regulate the activation and proliferation of satellite cells. It definitely does that. Satellite cells replication is initiated in response to secretion of inflammatory cytokines and growth factors, including insulin growth factor IGF-1. We want that when you eat beef. That is going to ramp that up like crazy. Hypocyte and animal fat. You need a lot of animal fat. Hypocyte growth factor, basic fibroblast growth. Well, that would be the collagen factor, nerve growth factor, leukemia inhibitory factor, whatever. What is this? Hepatocyte growth factor promotes satellite cell activation, but delays cellular differentiation, possibly throughout the inhibition of myogenic factors. Okay, stimulate. Okay, whatever. I'm not going to go through this, man. I'm tired of this. It's all about regeneration. You get the picture, okay, dude? Exercise in humans can induce the activation and proliferation of satellite cells. Exercise-induced release inflammatory substances or growth factors. Yeah, but if exercise could do that, but not if you're accustomed to doing it. It's not going to activate it. Get it? You're just waving your arms around, adapted, lifting weights, and getting nothing. That ain't going to do shit. Remember what it said up there, uninjured. It ain't going to do shit, bro. So yeah, and all these things pop out. It is recently shown that the number of satellite cells is enhanced on day 8 after a 36-kilometer run in group of endurance runners. Well, it happens. It happens. It's, there's something there going on in their muscles, some sort of damage. They're endurance. They're running really far. Your muscles are taxing. They're taking on a whole bunch of oxidative damage, oxidative stress, and a bunch of stuff, bro. Whichever. So yeah, it's a known fact. Now, in sprinting, you get damaged if you're doing things you're unaccustomed to doing, especially downhill running. It can happen in flat and fast, but you would have to do it many times over. That's why hill running is better for that. Okay, daughter cells replenish the satellite cell pool, whatever. Regarding training, satellite cell qualification, okay, whatever. You're just talking about bicycling, running, lifting, whatever. Even absence of myofibrillar damage, chronic low frequency, They talk about a whole bunch of stuff here, man. So, potential behind stem cell activation after exercise. Some ultrastructural muscle damage can be evidenced in human models using exclusively high mechanical load. Yeah, high mechanical load, meaning an overworking of that muscle, meaning a high mechanical load is not, they're not saying, well, we mechanically loaded a heavy weight on there and that's it, and now it got damaged. No. High mechanical load means that you're doing multiple repetitions to get it to micro-injure the fiber. Massive amounts of sets. Massive. Okay. However, most resistance exercise protocols do not induce extensive muscle damage. They don't. You want to know why? Because it has to be an overworking of an unaccustomed. It has to be unaccustomed to that movement. So I make it unaccustomed because I'm doing a full upper body, and I usually come back the following week. I'm totally repaired and remodeled, and then I'm doing multiple sets and reps for every muscle group because everything's getting worked in that one session. But I follow a pattern. There's a pattern that I follow, and it always gets damaged. It always gets damaged, trust me. And there's always growth. You head down to the buffet, especially after your workout. It's very important to eat for a couple of hours, especially after a damaging workout. Now, if you're not having damaging workouts, that's okay. You can go to your pizza shop and eat your pizza and eat your fake food and hang out with your friends and, eat a couple of pieces of watermelon and joke about how you're building muscles. Yeah, whatever. You can pretend build muscles. Therefore, the magnitude of changed satellite cells seen in exercise human skeletal muscle cannot be solely attributed to muscle fiber damage. Well, not entirely. They're talking about attributed to just the damage. They're attributing it to, what is it? I forgot what it said here. There's some protocols up there, whatever. Fiber necrosis and rarely has been reported in response to exercise. Okay. There is some contractile proteins being built as well from lifting. You could say contractile proteins are being built up, but nobody's building them up because, again, you need to be in positive nitrogen balance. It's really hard to build muscle. You have no idea. And you're not understanding when they're just saying, oh, well, not necessarily the damage. No, you need the damage. You need it if you want to further that domain. The release of inflammatory substances, cytokines, growth factors from active skeletal muscle, also from the surrounding connective tissue during exercise, repeatedly triggers the satellite cell activation, as previously mentioned. Yeah, lots of things can trigger the activation of it. Depends on what you're doing exactly. It is clear that skeletal muscle undergoes a certain level of tissue hypoxia. That's the one, tissue hypoxia. What is hypoxia? Well, that isn't based on lifting weights. The hypoxia, well, you're lifting weights, getting hypoxia. But it's not fucking muscle damage, okay? Hypoxia is a result of exercise training. Okay. People are going to say, well, I got hypoxia. The hypoxia or other factors secreted by skeletal muscle working on a very high overload may induce systematic stem cell mobilization. I'm not saying it doesn't. You understand me? That causes a degradation in muscle fiber, but that doesn't cause a micro injury to it. That caused degradation. That's totally different. It's degrading, which are then recruited to participate in muscle regeneration. It's regenerating what? The hypoxia damage. It's not regenerating the damaged muscle fibers from something that you did that was vigorous and unaccustomed to. Get it? See the difference? That's why they're trying to tell people, say to me, well, muscle damage is not important. No, yeah, muscle damage is important if you want to build more muscle fibers. But if you just want to regenerate muscle, yeah, it'll regenerate it because you're getting hypoxia damage. Is that going to get you growth? No, that's going to get you what? Regeneration of that hypoxic damage. How does hypoxia damage the muscle? It doesn't cause micro injuries to it or trauma. It causes hypoxia damage. Hello. So, but whatever, okay? So, yeah, so it stimulates the myoblast proliferation, It's just going to remodel. It's just going to, it's just going to repair the hypoxia damage. It's not going to remodel it. But whatever. Okay. In response to and they go on to tell you a bunch of stuff. That's why people don't even know how to read these things properly, don't understand it. They're talking to scientists. What's this one? As soon after exercise, changes satellite cell count evident? Yeah, it's evident. It's very evident, especially treadmill running. They did tests on it, okay? They know it's evident. It's not like it's not happening. Is interested in 7-8 subjects tested, demonstrated no evidence of myofiber damage. Yeah. They got hypoxia damage. They got other kind of damage. Okay, aging. A progressive decline in muscle strength may be the greatest contributing factor leading to an impaired physical function with age. It definitely is. Age-associated muscle atrophy has been shown to begin as early as mid-20s. And somebody's like, no, mid-20s, as early as mid-20s, you're already declining. Yeah, muscle decline accelerates, after which time the rate of muscle decline accelerates. So you're mid-20s, so at 25, right? In your mid-20s, at 25, after which time the rate of muscle decline accelerates. So you're skating uphill trying to build muscles now. The best time to build muscles is from age, I would say probably age 12 to 25. After that, it's just, it sucks, bro. But that's why I say you should learn how to do muscle damage when you're young and try to damage, repair, and remodel muscles. You have a better chance of building better muscles when you're young. When you're old, it's going to get really, really, really hard. Because why? Because it's on a decline. So if it's on a decline, you're fighting the decline and trying to go up at the same time. See what I mean? That's like, wow, that's a lot of work, bro. That's a lot of work. Sarcopenia and age-related reduction in number and size of muscle fibers seems to be what? Responsible for the decrease in muscle mass. Oh, it definitely is. Weakness ensues, resulting in an impaired mobility. All of you are going to get old and weak and whatever. You're going to fall apart because you don't understand muscle regeneration. You don't understand anything. So there's an increased risk for falls and a decreased physical functioning, yes. In addition, increasing age typically results in a decreased overall regenerative capacity, but I've actually increased my regenerative capacity because I understand how to regenerate muscles. That's why I go to the gym. My goals are not your goals. Go lift a heavy weight and waste my time while I'm actually degenerating. Yeah, that's all I want to do is fucking get old and start degenerating, but I want to show off and lift a heavy weight. Okay, bro. Okay. Yeah. Man, did you not read what this says? In addition, increasing age typically results in decreased regenerative capacities, increased susceptibility to muscle damage, and impairment of skeletal muscle regeneration in response to injury, and prolonged recovery. Oh, it sucks, man. It has all been said that all aging phenomena, tissue deterioration, cancer, propensity to infections can be interpreted as sign of aging levels, somatic stem cells, okay, whatever. There's a big decline in satellite cell count observed after 70 years of age and a whole bunch of stuff. And it has been recently shown that satellite cells obtained from aged skeletal muscle have an increased susceptibility for programmed cellular death when exposed to a what? Pro-apoptotic milieu. Well, that sucks. Along these lines, it has been shown that although satellite cells largely retain their myogenic capacity, but then there's a myogenic decline. You need to bring that up. Some studies have shown that satellite cells from aged animals demonstrate a decreased proliferative capacity. Whoa, that's very bad. However, the activity levels of the subjects seem the studies were poorly defined. Okay, yeah, but they already know what's going to happen. You're screwed, basically. I don't need to go any further with that. Then they're talking about diseases and other things and whatever capacities. I don't know. Functional research, acknowledgements. So this is the last part right here. Mechanisms underlying satellite cell activation, proliferation, response to injury, aging, and neuromuscular pathologies. Okay. I don't need to go any more on this. Okay. There's some this is really bad when it comes to spinal cord injuries. I have that problem. I have this problem. This could be one of the important factors leading to an impairment in neuromuscular function with muscle hypertrophy, and muscle weakness. For example, after a stroke, inflammatory nervous system disorders, I've kind of had that, and I have the spinal cord problem, this injury. Spinal cord injuries and diseases in the motor unit. I may have had diseases in the motor unit. I have nerve damage, and I have spinal cord stenosis. So you can imagine the uphill battle I was fighting. Now, I got injured in the gym. Somebody knocked me down. And man, it took me a full year to recover just from that. And that it just really impaired my squat, my bench, and just everything, bro. Just everything. It was painful to work out, painful to run. Just trying to run down the street in a sprinter, anything was just goddamn painful. You know that? And you have to be on codeine because of spinal stenosis and nerve damage because it's extremely painful. You have to take sleeping pills. I mean, it's such a bad thing. I don't wish it upon anybody. But like I said, me going to the buffet and eating in an anabolic growth state a lot of meat has really started to cure me. So I guess food is medicinal, dude. Anyways, I don't know what else to say there. I'm gonna bring up one more report really quick, okay? PubMed, satellite cell and aging, use it or lose it.
According to phys.org, they suggest that keeping dormant satellite cells healthy requires regular activation. The researchers conclude that people need to activate their muscles on a regular basis once they reach age 30, or face the possibility of losing the ability to regenerate muscle mass as they age.
Yeah, I would definitely believe her, and I'll tell you why. What's so good about muscle regeneration? Okay, so satellite cells and aging, use it or lose it. This is PubMed. So they tell you here it's going down with the age of 30, but over there they told you already at the age of 25, but they really mean 25. You stop growing at 25, you're going downhill. The most important part is this part, the regeneration part. Satellite cells are responsible for regeneration, skeletal muscle, and enter a reversible non-dividing state. Quiescence, homeostatic conditions. In response to what? Injury. Satellite cells are able to activate, re-enter the cell cycle, creating new cells to repair and create nascent muscle fibers while preserving a small amount to return quiescence and for future regenerative demands. Yeah, we already know that these things are important, definitely. However, in aged muscle, satellite cells that experience prolonged quiescence, they will undergo programmed cellular senescence, an irreversible non-dividing state that handicaps the regenerative capabilities of muscle. This review examines how periodic, they didn't say chronic, periodic activation and cycling of satellite cells through exercise can what? Mitigate senescent acquisition and myogenic decline. So there you go. What is senescent cells? They're zombie cells. They're accumulating. They don't divide anymore. They don't split, divide, or do anything in your body. They sit there and then they program the other cells to die too and do a bunch of weird stuff. That's why you look aged. Your skin, your body starts falling apart in age because you're accumulating senescent cells over time. You can accumulate a lot of them, especially on a phony diet. And myogenic decline, meaning that you're running out of the satellite cell pool. There's a myogenic decline in the satellite cell pool. That's why it's important to regenerate muscles. You want to regenerate muscles? You want to do regenerative bouts, unaccustomed regenerative bouts of eccentric exercise to regenerate muscle so that you can, what did it say here again? Mitigate senescent cells and what? And the senescent acquisition and myogenic decline. So mitigate senescent acquisition and myogenic decline. That's why you want to regenerate, especially as you get older, because I'm telling you, dude, you're going to be in big trouble. I'll see you in the next one. Tell me what you think about that video, friends. I'll see you in the next video. Ciao, friends. If I missed something, I don't know, let me know. Comment down below in the comment section if you want me to do something else. See you in the next one. Ciao, friends.